Welcome to All Things What. In this episode, we will be talking about what is the stellar parallax method and how it is used to measure distance of a star from Earth. Parallax relies on the displacement of an object when viewed through different locations. A simplest example is when you hold out your thumb against a background and when you look at your thumb with only your right eye and then only with your left eye again, the position of your thumb relative to the background shifts. By measuring the amount of shift and with simple trigonometry, we can figure out how far your thumb is from you. So in this example, what we have is the Earth that's revolving around the Sun. And what we are really interested in is finding out the distance of this star from the Sun. So I'll just denote it with D. What we know is the distance of the Earth from the Sun. This happens to be 1 astronomical unit, which is equal to approximately 93 million miles on average. On average is because the Earth revolves around the Sun in an elliptical orbit and it's not a perfect circle. So what we do first is observe the position of this star, let's say in January. And then we wait for 6 months for our Earth to revolve around to the other side. So this is maybe in June. And we observe the position of the star again. So what we determine in this two observation is really the angle of the observation, of the displacement. Well, denote it with theta. This happens to be called the parallax angle. And what we are interested in finding out is this D. So if this is theta, this is theta by 2. And by applying simple trigonometry, we know that tan of theta by 2 is opposite. So this is 1 astronomical unit. 1 astronomical unit divided by adjacent, divided by D. And I would rewrite it to 1 AU divided by 10 of theta by 2. So with this we can figure out the distance provided we know the angle of the two observations that are made. Now there's a limit to how well this method works to measure the distance of the object. As the object is further and further away from us, the parallax angle becomes extremely difficult to discern. So you can imagine if limit theta tends to 0, in that case tan of theta by 2 will also be 0. Right, tends to 0. Hence there is the limit of figuring out how far an object is from us, and with this method it's around 300 light years away. So if the object is about 300 light years away, we can with high confidence use the stellar parallax method to figure out the distance. For anything more than 300 light years, we will look into two other methods at a very high level, since these warrant a video by itself to deep dive. In the first approach, we call it the cepheid variation. With this approach, in the early 1900s, an astronomer named Henrietta Swan Leavitt from Harvard College Observatory discovered that certain stars cycle through its brightest and dimmest luminosity in very consistent manners. So these were called the cepheid stars. And more interestingly, there was a correlation between the luminosity and the duration of the cycle. So more brighter the star, the longer it took to cycle through its luminosity. So in this chart, if the star was very bright, it took longer time to cycle versus a star that was more on the dimmer side, took a shorter period of time to cycle through its phases. So using this approach, if we want to find out the distance of a star, we observe the period it takes to cycle through it first. Once the period has been measured, its absolute luminosity can be determined from a known set of behaviors from cepheid variables. So basically compare it to this chart. Comparing the absolute luminosity with the apparent luminosity seen from the Earth, we can determine the distance of the star since the brightness drops with the square of the distance. With this method, it allowed us to measure distances up to millions of light years. For objects that are billions of light years away, we use another method that uses redshift and the Hubble constant. Essentially, in this method, we look at the electromagnetic spectrum of the object and see how much shift in the lines of its spectrum. So an example here is if we have a galaxy A and a galaxy B, right, we can see that from the spectrum of galaxy A, there has been a shift, and from galaxy B, a more red shift. So we can assume that the galaxy B is moving away from us at a faster rate than the galaxy A. With this and the Hubble constant, we can determine the distance of the object from us. So in summary, in this video, we have learned 3 different techniques to measure the distance of the star from Earth. The first one, we discussed in detail the parallax method, which is accurate for stars up to 300 light years away from us. In the second, cepheid variation, we touched upon how it is used to measure distances up to millions of light years away from us. And lastly, the redshift, in which it is used to measure distances in the billions of light years away. Thanks for watching this episode, and stay tuned for more on all things what?